Okay, your homework that will be due Tuesday is this. Write it down. 5.4, number 6, 9, 11, 14. I was trying to figure out a way to make this easy over the weekend, but there isn't one. So what I'm going to do is I'm going to make 3 different videos. I'll just break them up into 3 different parts so that it's easy to find later if you want to rewatch. So I'll do a problem that's similar to number 6, I'll do a problem that's similar to number 9, and I'll do a problem that's similar to number 11. I expect you to at least watch the first 2, and maybe even all 3 before class tomorrow. But you can watch that one during class tomorrow, the one that's like number 11, because I think that's the hardest one. Maybe not, I don't know. And then, yeah, you'll have the whole class tomorrow to try to get those 4 problems figured out. You can work together. I recommend going into class tomorrow with try on your own, because it's much more important to be able to do it on your own. So try them all on your own if you can. So anyway, I'll start with the problem that's similar to number 6, and it's number 5. This is just right out of your book, the homework problem, and 5.4. Number 5, it gives you a picture. And these are similar because they both take place on the coordinate plane, and they both are about finding maximum area, I think, of a rectangle that fits in between a couple lines. So in this one we got a rectangle, a triangle that has vertices at -1 and 1, and it goes up and makes a right angle, and you get that. That's point B. Let's see, what else do we know? Oh, so the whole idea is you take a rectangle inscribed into this triangle. So you can go as far out as you want from 0 here, and you go up till you hit it, and then you go over and down, and you make a rectangle, and you're trying to get the biggest area for that rectangle. So should I come way down here like this and make it skinny? Or should I just go over here like this and make it skinny that way? That's what we're trying to figure out, is which rectangle gives you the biggest area. So in order to do that, we need to figure out the dimensions of our rectangle, right? Because I think that I'm not really going through each problem A, B, C. I'm just going to kind of talk through the whole thing to get the largest area for that rectangle. Well, we know for a rectangle, area is equal to just length times width, right? Well, so now we need to write, what do we know about our length of our rectangle, or this way? Well, since we're on a coordinate plane, however far I come out this way, it will be x, right? And then the whole length of my rectangle, wouldn't that just be, if you come out like half here, and then you go up, aren't you going to hit half here? Because these lines are basically the same. Oh, I forgot. It tells us it's an isosceles triangle. The one you're going to do is much easier. You have the equation. It's an upside-down parabola, and you're doing the same thing in an upside-down parabola. Because what we need to do is we need to figure out how far out, coming out this way, and then how far is it going to be this way. So we have to put a point here and say that point, the coordinates of that point would be x, comma, well, we got to figure out what goes there. Because that'll help give me the dimensions of my rectangle, the length and the width. Right now I know the length is just 2 times however far I come out on x. Because, the part I forgot, it says it's an isosceles right triangle. So those are the same. So if those are the same, those lines are the same, and it's going to work out nice. So our length, I know that, so the area of my rectangle is going to be 2 times x times whatever the width is here. So in order to get that, I think this is part A in the book too. It says, find the equation of that line. It's nice, and the one you're going to do, you already have the equation of the parabola, so this step you won't even have to do, because this requires geometry. If you got an isosceles right triangle here, see here, well, if those are the same, you know those angles are the same. If those angles are the same, you know they're each 45. So if you have this, That has to be 45. Well, then right here, just breaking it in half, you have another right triangle. Right? So if that one's so that's a smaller 45, 45, 90. And for that small right triangle there, I know the length of this bottom side is 1. Well, if that's a 45, 45, 90, that tells me the length of this side also has to be 1. And if I know that's those 2 points, like 1, 0, and 0, 1, I can write the equation for that line. Hey, the slope's down 1 over 1, so it's y equals negative x. Y-intercept is 1. So the equation of that line is y equals negative x plus 1. Like I said, on the one you have to do, that's already given to you. So now to figure out the coordinates here, if this is x, well, using the equation of my line, I get the points along the line, right? So this would be, the y value of this point would be negative x plus 1 from right here. So like if x was half, y would be a half also. If x was 3/4, y would be 1/4. So there's the coordinates of my point. So now I can figure out the width of my rectangle. It's just going to be, however, if I go over, like I said, if I go over 3/4, the y value will be 1/4. So that y value there is the width of my rectangle. So there's my equation I'm going to use for the area of my rectangle. I just need to maximize it. And I think this is, oh no, this one is a calculator problem. Just for fun though, let's do it without a calculator. Because you said, you guys keep asking how to do it without a calculator. Well, here's my function. If I want to get the maximums, it's just like extrema. So I got to do the derivative of it. Well, I don't want to do product rule, so I'll distributive property it and get negative 2x squared plus 2x. Take the derivative, so a prime will equal negative 4x plus 2. So the extrema happens where the derivative is 0, right? So subtract 2, negative 4x equals negative 2, so x equals 1/2. Now I gotta check, make sure is that a max or a min. So here's a half. I can't go below 0 on the x because I can't have negative x because that'll just repeat. You could do negative x, but then it's the same as positive x in this case because you're just going to build a rectangle in there. But over here, so what, like plug in like a quarter. 1/4 times 4 is 1. It's negative, so negative 1 plus 2 would have positive here. And then plug in like 3/4. 3/4 times 4 is 3. Negative 3 plus 2 is negative. So it goes from positive to negative. Hey, that's a max. So for this function, for my area function, my maximum area happens when x equals 2. Or 2, not 2, 1/2. So the question asks the largest area we can get and the dimensions of the rectangle. Well, so our dimensions of our rectangle we know when x equals 1/2. So we're going to come out 1/2. So our rectangle, we're going to come out 1/2. And then my y value then would be negative 1/2 plus 1, so that'd be 1/2. So really, my dimensions for my rectangle, the length, remember if x is 1/2, the length there is 1. And what are we in, inches? I don't know. There were units. There weren't units. So the length is 1, and the width is 1/2. So what is the maximum area? Well, 1 times 1/2 is 1/2. That's just units squared. Area is 1/2. Or the other way you could have got that is taking your x equals 1/2 and plugging it into your equation. 1/2 squared, or just plug it in up here, it's easier. 2 times 1/2 is 1. Negative 1/2 plus 1 is 1/2. 1/2 times 1, 1/2, I get 1/2. So the maximum area is 1/2. Length is 1, width is 1/2. So I believe on the one you're supposed to do Yeah, you got an upside down parabola, right? Remember how to graph 12 minus x squared? I hope you do. It's the same as negative x squared plus 12. That shifts it up 12, and that's just going to flip it upside down. So it's an upside down parabola. That point's 12. So remember, you're going to have a rectangle in here. So yeah, this will still be x. The point on there, well, hopefully you can figure out what that is and go from there and do this whole process. I don't even know what I just did. Who cares? That's it. That's it for that one. So that's very similar to what you're going to do here.